Thank you so much for joining us. Folks, my guest today is Arvind Narayanan, who is a professor of computer science at Princeton, but also one of the keenest observers of the social and economic issues around AI. He is, I guess I would say, the smartest contrarian I know to the AI hype. He has a wonderful book called AI Snake Oil, which is also a wonderful blog post. I mean, sort of Substack. And most recently, he has gotten a lot of attention for a paper that he wrote called AI as Normal Technology. And I think that the concept of a normal technology is one that may seem unexpected to you, because AI certainly doesn't seem normal. But when you understand exactly what he means by that, I think it will be a really useful tool. For me, ideas are tools for thinking. And Arvind is somebody who creates amazingly useful tools for us all to think about the problems we face. So with that, I'm going to just start out. Arvind, you can talk about anything you like, but I would really love to have you start out by giving us kind of what do you mean by this AI as normal technology, and how do we how should we be thinking about what's going on today?
Yeah, thank you, Tim. So this paper, AI as Normal Technology, is co-authored with Zayesh Kapoor. You can look it up, but I'll give you a very high-level overview. So let me start by pointing out that the first two sentences of the paper go, we articulate a vision of AI as normal technology. To call AI normal is not to understate its impact. Even general purpose technologies like electricity and the internet are normal in our conception. So I wanted to put that out there right off the bat, because some people put us into the AI skeptics bucket. I hope it's clear from the opening of the paper that that's not where we're coming from. We do think this technology is going to be profoundly impactful. So what do I mean by normal? There is, it turns out, a well-established theory of the way in which technologies are adopted and diffused throughout society. So the key thing to keep in mind is that the logic behind the pace of advances in technology capabilities is different from the logic behind the way and the speed in which technology gets adopted. That depends on the rate at which human behavior can change, organizations can figure out new business models. And I don't mean the AI companies. There's too much of a focus on the AI companies in thinking about the future of AI. I'm talking about all the other companies who are going to be deploying AI. I think that is a much more interesting locus to understand how AI is unfolding and is going to unfold. And we take that well-established theory and we adapt it to AI, and we argue that AI is no exception. It has been not an exception so far, will not be likely an exception in the future. And we look into the claims that superintelligence is going to happen at some point, and at that point, AI is going to be, very different from any technology we've encountered before. I have a lot to say about that, but I'll keep this intro short. But basically, we don't think the arrival of recursive self-improvement, for instance, if that were to happen, will be an exception to these patterns. So, and one or two last words. We talk a lot about AI safety in the paper. We're glad that many people are thinking carefully about AI safety. We don't think it requires any extraordinary steps like, pausing AI or banning open source AI, or things like that. Safety is amenable to well understood both market and regulatory interventions. And the last thought I will say for now is that when we say AI is normal technology, it's not just a prediction about the future. Really, the core point, one of the core points of the paper, is that we have the agency to shape it as normal technology. We have the agency to ensure that the path through which it diffuses through society is not governed by the logic of the technology itself, but rather by humans and institutions. So I'll stop there.
Yeah, sorry, I want to ask you to go a bit more slowly. And what I mean by that, I've kind of made this a theme here. It's based on a story from Proust where a friend comes to visit him, and he says, tell me about your day. And the guy says, well, I just came in from where it was on the train. He says, no, more slowly. And he keeps asking him that until he's telling him all these details, like the old man feeding the pigeons on the steps of the train station. And it makes me think of, in this case of normal technology. I remember a talk that Jeff Bezos gave back in the early days of Amazon. He and I both spoke at an all hands meeting, so I got to be at one of their all hands meetings. And it was this fabulous talk about electrification and how, why it took so long. Nobody had invented the light switch. The early, nobody had invented the plug. All you had were lights.
Exactly.
And there were all these things that had to be figured out, motors. Anyway, so can you maybe give us a bit more of like, what are some of the, like, if you take that frame of why technologies take a long time to diffuse because of the innovations that aren't there yet, what might be some examples of that we've already seen with AI?
Definitely, yeah. So this really gets to the meat of the paper. So we present a 4-stage framework, and again, it's adapted from classic frameworks, but it's specific to AI. So the first stage is invention. So this is improvements in model capabilities. And that has been talked about endlessly, so I won't say too much about that. But just like in your example of electricity, people don't use electricity directly, they use electrical applications. The model capabilities themselves have to be translated into products. Now, in the first year or two after ChatGPT came out, the AI industry seems to have somehow thought that AI is an exception to this. We'll just put models in people's hands and they'll figure out what to do with it. I mean, for simple questions like formatting an email or whatever, that's fine. But when it comes to using AI for software development, for instance, just to give one example, that has not worked out at all. You really need to figure out these user interface innovations to allow, for instance, software developers to do the right context engineering so that they can use these powerful but flaky tools in order to work with, a 1,000,000-line code base, given that you can't just stuff the whole code into an AI model and ask it to do whatever. So that's the second stage. That's product development. And we're still early in the second stage of figuring out what the right abstractions are through which this very unreliable technology of large language models, as one prominent type of AI, can be fit into what we have come to expect from software, which is that it should work very deterministically, which is that users, once they've learned how to do something, that their expectations will be fulfilled. And when those expectations are violated, we see that AI product launches have gone very horribly. So we've had these personal assistant devices, for instance, like the Rabbit M1, if folks remember that. These are very highly capable assistant devices. But the reason they flopped totally is that they were unreliable. If you try to order DoorDash and it works 90% of the time, but 10% of the time it sends it to the wrong address, which are the kinds of errors that people are reporting, which we've never had to worry about with traditional software, then your product is dead on arrival, right? So figuring out the right abstractions for product development, that's stage 2. Stage 3, this is part of diffusion, but it's the first part of diffusion. It's early user adoption. So early users figuring out use cases, workflows, risks, how to route around that. All of that is happening in some areas, but in other areas, even that is too early. And the last and most time-consuming step is adaptation. So not only do individual users need to adapt, industries as a whole need to adapt. In some cases, laws need to adapt. What do I mean by that? I'll give 2 quick examples. Going back to your example of electricity and why the electrification of factories took so long, from what I understand, what people tried to do at first, the factory owners tried to take their big steam boilers and replace them with electric generators. That did not bring them any real improvement. It took many more decades to figure out that the right way to use electricity in factories was to reorient the whole layout of the factory around the logic of the assembly line, so that electricity could be moved or generated wherever it was needed instead of one big generator that is turning a crank and then trying to do work just based on that one generator. Similarly, we think these kinds of adaptations to organizational structures, business models have to happen in every industry. One last example, let's take software. So some people hope that in the future it becomes possible, just like we can vibe code small apps now, that it becomes possible to even build much more complex pieces of enterprise software just based on a prompt. Okay, suppose that's possible. I don't know if it's going to be, but suppose it becomes possible. I claim that in that world, it will make no sense for these enterprise software companies to build software once and then force thousands of different clients to use it to adjust their workflows to the abstractions defined in the software. That's not going to be how we'll use software in this future world. What will happen is that developers are going to work with each downstream client, understand their requirements, and then perhaps generate software for them on the spot so that it meets a particular team's needs or a particular company's needs or even perhaps a particular individual's needs. So this is a complete reconceptualization of what enterprise software even means. And this is the kind of thing that we think is going to take decades. And it has little to do with the rate of AI capability improvement.
Yeah, Arvind, there's one other piece that you didn't talk about in there, and I wonder to what extent this fits in your theory, and that is the development of the actual infrastructure. I also remember a story. Actually, it's fictional, but from the book "The Magnificent Ambersons," in which this family invests in the the automobile has taken apart their family fortune, and they're trying to get back in the game, and they invest in headlights. But it turns out the roads are so bad that the alternator, can't support the battery for the headlamps and so on. So it's this kind of thing, like the roads really were a big part of the rollout of the automobile, not just the automobile itself. And and in the case of AI, we kind of have this creaky energy infrastructure that's not going to support. We have chip bottlenecks. We haven't really figured out what the networking demands are going to be, where the distribution of the intelligence, is it going to be centralized or distributed? So where does the infrastructure layer fit into your model?
Yeah, completely agree. I mean, historically, when we look back at what were some of the speed limits to getting where we are today, the key technique, deep learning, that powers today's frontier AI. The principles behind deep learning were published in the 80s, if not before, and their significance was recognized back then. But the reason it took many more decades for deep learning to really start proving its mettle was simply that it had to wait for the invention of GPUs. So we've had examples in the past where the infrastructure was really the bottleneck. That could be the case today. It's probably the case today. But I think we would need the benefit of hindsight to even know, oh, this was the particular infrastructural bottleneck, right? So it could be the things you said. It could be things like people are not comfortable running all these AI models in the cloud. The thing that's really going to make AI take off is if everyone can, run it on premises, but then we don't have that kind of decentralized infrastructure yet to be running AI for all the workloads that we want.
Yeah,
it could be.
I think that's right. Yeah, and in fact, we saw already one moment of this with DeepSeek. I want to ask you just a very timely question. The rollout of GPT-5, was widely hyped. It's sort of like this is we're getting closer and closer to superintelligence, and then it comes out and maybe not so much. What do you think about what is this telling you or telling us about your theory?
Yeah, I think the marketing around GPT-5 was so weird. On the one hand, there was all of this hype around superintelligence, and then there was that one famous viral clip of Sam Altman going, "Oh my God, what have we done?" It's the usual kind of hype that he puts out. On the other hand, I think what OpenAI actually intended to achieve with this release was to unify their different models, simplify them for users, make the models faster, more cost efficient in order to bring, largely existing capabilities to more people. I think from that modest, in terms of those modest ambitions, we can call it largely successful. However, like you pointed out, there was so much hype built up around this. And because of that, people are rightly very disappointed. And I think it really fits with the normal technology thesis. So there has been this assumption that just because AI is so powerful, if we were to assume that it is very, very powerful in terms of capabilities, it is getting adopted unprecedentedly rapidly and faster than any other technology in history. All of these are based on dubious statistics, some of which we dispute in our AI as normal technology paper. The rest of it we're going to be disputing in future work. But for now, let me just give you one example from the rollout of GPT-5 to illustrate how slow diffusion is, even if the technology is very powerful. So there's these quote unquote reasoning models, whether they're actually reasoning is a different question, but the industry calls them reasoning models. I'll just use that term. The models like O3, they're actually very useful. They can do a lot of things that non-reasoning models can't, and they started to be released around a year ago. And it turns out, based on Sam Altman's own admission, that in the free tier of ChatGPT, people were using them. Less than 1% of users were using them per day, and in the paid tier, less than 7% of users were using them. And then because of the rollout of GPT-5, it can automatically pick reasoning models when it thinks it's called for those numbers bumped up a little bit, right? So this shows you how much diffusion lags behind these capabilities. I mean, these models have been out for a year. There's been endless hype about how it can solve, International Math Olympiad gold medal problems and that sort of thing. They are genuinely useful, but less than 1% of people were using them a year later. And so it's exactly an illustration of the point that diffusion, changes to user workflows, learning new skills, those kinds of things are the real bottleneck.
Yeah, or even just knowledge, and habits.
Yeah. And even more basic.
And what about this sort of backlash where people were going, I miss my GPT-4, the personality is different. That was certainly an unexpected effect that people have become attached to the style and the voice of a particular AI. The psychological, connection that people are making.
Yeah.
And again, that's definitely a factor that I don't think we had planned for.
Agreed. I was taken aback by that as well. Let me make 3 or 4 quick points about this. One, I think this is going to be interesting to see how antitrust regulators deal with this, because pretty soon, I think these these chatbot developers are going to have real market power. And in the past, we've had to deal with switching costs, but those switching costs are a matter of, moving your data from here to there and that sort of mundane thing. But now what switching costs mean is that you've developed an emotional bond with this companion, and that's getting broken. And it's kind of like going through a breakup, right? So our regulator is prepared to deal with this new, harder to quantify, but really much deeper kind of switching cost. I don't know, and it worries me. The second thing I'll say is I think what a lot of people liked about the older version was the sycophancy. And I think GPT-5 was less of a sycophant, and people hated it, even though they wouldn't put it in those terms and they wouldn't like to admit it. So that's worrying, right? So there's strong pressure from customers on these companies to make their bots more sycophantic. So how is that going to play out?
Speaking of
third, I think,
finish your third point.
Yeah, I think so. Sam Altman's response to this has been, we're going to basically start customizing these models to everybody. And again, that's a very interesting move, and its effects are unpredictable. Everybody's AI is going to behave differently.
Yeah. I was just thinking of, when you're talking about sycophancy, I couldn't help thinking there's a recent post by Sam Scalacci, who's the deputy CTO at Microsoft, most famous as one of the original creators of Google Docs. But he basically had a post where he said rich person's disease. He says rich people kind of they're surrounded by sycophants, and that has a distortive effect on their perceptions and behavior. He said now everybody has rich person's disease because of sycophantic AI, and I thought it was a great concept.
Yeah.
So that kind of brings me to one of the attendee questions. AP asks, do you have any thoughts on the new Illinois AI mental health law? Now, I don't know what that is. We could maybe look it up. It doesn't just ban chatbots, but I'm not looking forward to 50 jurisdictions of rules. Now, I totally
that's fair.
agree.
Yeah.
Fragmentation of jurisdiction of AI, but do you have any thoughts on that?
Yeah, so two quick comments. One on the jurisdiction question. I mean, look, this has been a highly partisan thing, and I'll just describe what is happening and not express any opinion on it. The Biden administration tried to promulgate various rules for AI, given that Congress is not really acting. But the thing with executive orders is that they can easily be reversed, and of course, the Trump administration has reversed them, and again, Congress is not acting. And so, what, regardless of the pros and cons of 50 jurisdictions, that's what we're getting. Whether it's with mental health or with anything else, the states are very active in terms of AI regulation. Last year alone, more than 1,000 AI-related bills were introduced in the 50 state legislatures, and dozens, probably more than 100 of them, have passed. And yeah, we are living in a patchwork, and it's only going to accelerate. So that's on that. But in terms of the specifics of the law, and I'm not a legal expert, but broadly, my understanding is what it does is it prohibits the use of chatbots in therapy. I might be oversimplifying a little bit. The big question for me is, does this mean that if people turn to ChatGPT and ask for mental health advice, that OpenAI is required to fine-tune the bots to actually reject that advice? That is, I think, by far the biggest kind of mental health use of chatbots that's going on right now. What's clear is that if you have specifically built a chatbot that's advertised as a mental health assistant, then you can't, advertise or make available that chatbot in Illinois. Again, not a legal expert, but it seems fairly clear from my non-expert reading of the law. But it doesn't matter if people are going to be able to turn to these general purpose chatbots, which are not advertised as a mental health assistant and therefore might potentially escape the scope of the regulation. And if that's the case, it's going to end up not having a lot of teeth. So it remains to be seen what its effect will be.
Yeah. I mean, one thing I remember talking with one of the Google member of the Google regulatory compliance team, and she said, look, one effect of this fragmentation of regulation is it really favors big companies because we have the legal staff to deal with it. Small companies don't. And that's something we should all care about if we're in an entrepreneurial world. The more complex the regulatory frameworks get, the harder they are to comply with. And anyway, but let's move on. I have another question. HM asks, what superhuman AI implementations might make you question your thesis? For example, if at some point we see people preferring AI teachers, psychologists, advisors, et cetera, over human ones.
Yeah, definitely. So I think the biggest thing we should watch out for is if superhuman persuasion is possible. This has been predicted for a long time. It is not, my understanding of the research is that it's not even close to true right now. And I don't think that'll change in the future. So let me explain what I mean. One of the biggest worries with superintelligence is that our ability to control it will be basically non-existent because whatever controls we try to put in place will ultimately be administered by some humans in charge of it, and AI will be able to basically talk them out of it, right? So if that's ever going to be the case, then we're in trouble. We don't think that's going to be the case because this is not a task at which, just by AI models getting clever, you're going to be able to craft a message that is somehow so powerful, like such a mind worm or whatever, that it's going to cause people to act against their own interests. And when you specifically define the task like that, getting motivated humans who are motivated one way to act against that motivation, it's not clear that all of this improvement in model capabilities so far has made models any better. There's a lot of research on persuasion that's like, oh, if someone believes in a conspiracy theory, these models are very good at patiently explaining the facts to them and then talking them out of that. That's a very different kind of capability than, being this supervillain that's going to convince a person to let an evil model out of the box, let's say. And so that's one thing that would cause us, if that ever happens or is close to happening, it would cause us to revise our views significantly. People preferring AI companions, I mean, look, that is an existing danger. That's not even something that might happen in the future. And that is something that concerns us. But it's not something that we're it doesn't cause us to think that we should take dramatic measures to curb the development of AI, for instance. So that's very different from the superintelligence questions.
I think it's also it really highlights a key point of your normal technology framing, which is that having a big social impact or unexpected social impacts does not make a technology not normal. In fact, it is a characteristic of normal technologies. I mean, the automobile, nobody expected it to create the suburbs. Nobody expected it to exacerbate, global, climate change. Nobody expected the kinds of pollution that we would have, lead, all those kinds of things were unexpected harms. And nobody expected that, cell phone use would lead to lower sociability in the, Zoomer generation and below, So speaking of which, RR says, I'm representing Zoomers in an upcoming AI debate. What statement would you mention to help me win it? I'm not quite sure. That's a pretty broad question, but if you have any thoughts on thinking about AI and Zoomers, that might be worth working in. But I guess the point is, normal technology does not have huge impact, huge unexpected impacts. It just means it takes longer to figure out what those things are, and it doesn't happen overnight. So is that a fair summary of the? And it doesn't happen overnight for a lot of complex reasons that we don't necessarily understand until we look backwards.
Yeah, it's perfectly said. Nothing really to add to that.
Yeah. All right. Well then, okay. So GL keeps pushing on this. He says, when comparing AI to other technologies to define it as normal, what other technologies have been non-deterministic in the way current AIs are, and how does this impact technology adoption?
Well, I mean, depends on what non-deterministic means. At a technical level, I guess it's pretty unusual that compared to previous waves of software, at least, AI is a technology that is stochastic. And so we're having to do a lot to figure out how to use it productively in our workflows. Very much so. But in terms of non-deterministic, in terms of the way it is deployed in society, I mean, in the ways that matter to me, like cars are non-deterministic. You can't predict when accidents are going to happen. And that was one of the biggest things with auto safety regulation, right? So the regulation had to accommodate for that non-determinism. And so it led to things like, when an accident does happen, do you blame the driver or the manufacturer? Obviously, in most cases, both are somewhat at fault. But as you might know, in the early days of auto safety, the manufacturers wanted to put the entire blame on the driver. If all drivers involved in the accident had been perfectly careful, the accident would not have happened. Maybe so, but because of advocacy, most famously by Ralph Nader and many others, society came to view it as partly or largely the manufacturer's fault and decided that it was, in fact, justified to put a lot of safety requirements on the manufacturers. So in that sense, we have a long history of knowing how to gradually figuring out how to deal with these technologies with non-deterministic effects, either at an individual level in the case of auto accidents, or as we're figuring out now at a societal level, as Tim pointed out with cell phones. So a lot of these emergent effects have been unpredictable, but we're figuring out how to deal with them, and we will gradually, painfully, slowly figure out how to do so with AI as well.
Yeah, I was at an AI governance workshop with a bunch of lawyers recently, and my big takeaway from that was the legal point of view on all this is regulation should follow torts, because basically that tells you where the pain points are, and I thought that was my really useful takeaway from that. A lot of, it turns out the history of steam boilers is a really key piece of technology history, where they used to explode. And again, whose fault was it, and how do you think about that, and how do you make liability rules for that? And that leads me to the question from RG, who says, Meta recently won a U.S. lawsuit where it was ruled that the scraping of copyrighted content, in this case books, was fair use. Does this ruling imply that scraping of any copyrighted content, such as films, proprietary software code, and so on, is also fair use? And I think it's more complex than that, but let's just see what you have to say about that. But this is a great example. Copyright is one of the great areas where tort is showing us that, yes, there is a need for regulatory interventions or market interventions. Because going back to automobiles, auto insurance was invented as a market response to some of these liability issues.
Exactly. Yeah. So there were two of these lawsuits recently, and I think I'm thinking of the right one. This was Judge Vince Chabria, and he was like, the plaintiff's complaint really sucked in terms of how they made the legal argument. If you had argued it slightly differently, the plaintiffs would probably have won, which was a very unusual thing and seemed like a strong signal that even though this particular lawsuit went Meta's way, it might not be so in the future. So I think it's too early to declare victory for the tech companies. But that said, I'll say that while my moral sympathies are with the plaintiffs in this case, I don't think copyright is the right way to bring justice to the authors and photographers and publishers and others who have been wronged, who genuinely, I think, have been wronged by these AI companies using their data without consent or compensation. And the reason for that is that it's a labor issue. It's not something that copyright was invented to deal with. And even if a future ruling goes a different way, I think companies will be able to adapt their processes so that they stay clear of copyright law, while nonetheless essentially leaving their business model unchanged. And unless you can change their business model, force them to negotiate with these creators, with the little guy basically, and work out a just compensation agreement, I don't think justice will be served. And that actually requires new policy and new legislation. And I think it's unfortunate that so far there doesn't seem to be any movement on that front.
This brings up just a key idea, which goes back to why this normal technology framing is important, but also just in general, why the way we think about a problem shapes how we respond to it. And for example, in this case, you're making a really key point, which is we've thought about this as an intellectual property issue when in fact it's a labor issue. Profound reshuffling of how we should approach the problem. And of course, there are a lot of people, yourself included, who are looking at the labor impact of AI. Do you have are there other aspects to that reframing that you could go a little more deeply on?
Yeah, certainly. I can share the current thinking that Sayash and I have on what AI's labor impacts might be. So while we're not in the camp that is predicting, apocalypse by the end of the decade and half of white-collar workers will have lost their jobs, nonetheless, we think that the impacts are going to be significant. Certain occupations might be decimated. And those often tend to be cases where it's not so much because of the technology and not so much a question of, is the technology capable enough to carry out the tasks that are currently carried out by these specific human workers? It's more about what are the labor protections that currently exist for that particular occupation? And if something already operates on a gig work model, so consider translation. So if translators are primarily doing gig work, right, where they contract to translate an article or a book or something like that with a new party each time, and that's done over the internet, they have no actual relationship with whoever they're translating for. It becomes very easy once AI reaches a certain capability level to just automate it instead of using a human translator. But if you think of a translator as someone who is embedded within an organization, whether it's a publishing house or let's say the United Nations, which needs to translate to various languages, who actually understands the particulars of that organization. And what they bring to the table is not merely their knowledge of languages, but the understanding of that organization that allows them to do a better, more contextually appropriate job than a model might, then it becomes much easier to understand why it's not so easy to replace that person with a model, right? So really the key question for AI and labor is the structure of the arrangements between the firm and the worker rather than a comparison of AI versus human capabilities. Lots of other thoughts, but I'll start with that one.
I can't resist telling a story I once heard Jimmy Carter give in a talk after he was retired. He told a story when he gave a long talk at Japan. In Japan, he opened with a long joke. The translation was very short, and everybody laughed. And afterwards, he said, I went and I asked the translator about that, and he said it was a long, complex joke. So I said, President Carter told a funny story. Everybody laughed. Man, that would only probably work in Japan, but it does indicate the exact kind of insight you were talking about from a human translator in a live situation that would be. Anyway, let's move on. This is kind of interesting. We're just talking about the UN. So ZB says, which entities would have incentive and ability to use AI for solving global problems?
Which entities? Yeah, the UN for one, but really anybody. I think. What makes something a global problem, right? You could call something global because it requires international cooperation. You might call something global because every country faces a version of the same problem. You might call something global because you're specifically talking about developing countries. So I think all of those have slightly different answers. I think there are many entities who are specifically looking at the role of AI in developing countries, and I think there's lots of reasons for optimism there. I think that in some cases we even see instances of leapfrogging being a concept from international development, where a developing country skips over one technology generation and moves over to the next one. And so we see lots of countries digitizing at the same time that they are deploying, starting to use AI for various things. That actually brings a lot of benefit because they don't have to deal with their now antiquated processes that were built around an assumption of pre-AI software that's kind of more deterministic, doesn't necessarily require humans in the loop. So if you're starting from scratch, you can actually better deal with a lot of the idiosyncrasies of AI, including its non-determinism that we have talked about. Various other advantages. So I'm pretty optimistic about the role of AI in developing countries. Now, one other quick thing I'll point out is that a lot of the problems that come up with AI are going to be shared between many different countries. And the usual answer to this is, this requires uniformity in our legal and governance approaches. It requires the UN, et cetera. Maybe in some cases, for sure. Of course, there's a role for the UN. But in a lot of other cases, it's really good to have this more of a laboratories for democracy kind of approach, where each country kind of tries its own thing, and gradually we figure out what's working better and what's not working so well, and we learn from each other.
Yeah, it's interesting. This relates to another question that's in here. DR says, how do you see AI transforming robotics in the near future, and what kind of real-world impact could that have? Now, I just recently was having a conversation with a Chinese venture capitalist who said there's a lot of investment in that area in China, precisely because of cultural and economic differences in the willingness of businesses to pay for enterprise software, the willingness of consumers to pay for software. So there are, and this again is your normal technology thesis, there are sort of culture and economic forces that channel innovation, and so they're spending a lot of time on innovation. And I think this is going to be true around the world, where people are trying to solve local problems with AI. To the extent that it's widely deployed, we're going to see more of that laboratories of democracy or laboratories of innovation. So that, of course, being a reference to Judge Brandeis talked about the U.S. states. But it's just true, when you have different markets, people go solve their own problems in different ways. But do you have any thoughts on this question of AI and robotics and what kind of real world impact that could have?
I mean, what you said is a great insight. And actually, if you want to go deeper into the reason why China is going in a different direction, you were explaining to me before we got on the webcast. I found that super interesting, to be honest.
No, but I was just more thinking just about in terms of, let's just take our, sort of U.S. Western context. and this sort of question of labor issues. Are there any potential impacts in this? You know, robotaxis probably being the first and
Yeah,
most
yeah,
obvious
yeah,
one.
yeah, exactly. Yeah. So, I mean, again, this is an area where our predictions about the speed of impact are, more conservative than what you hear about in the news a lot. But we do think the impacts are going to be profound, both in terms of the labor impacts and in terms of the positive safety impacts. And I think that almost goes without saying. I do think the arrival of self-driving technology should be celebrated. I think the approach that labor movements are taking right now is maybe not so great, which is just kind of blanket opposing the technology, to oversimplify a little bit. It's not clear if the right political forces are aligned to, again, both welcome the technology but also compensate those who are going to be harmed because of the automation.
Yeah. JB asks, what are your thoughts on AI hindering our critical thinking, especially in the area of education?
Yeah, that's a big one. And I look back at the effects that the internet had, and what I see is it's something kind of bimodal. On the one hand, you see kids who are really good at using digital technology in the right ways, in ways that enhance their learning, their critical thinking, and so forth. But on the other hand, you also see, again, forget about AI for a second, right? Previous waves of digital technology to, whether to cheat on homeworks or spend time on addicting social media apps or games or whatever. So overall, I would say it's really helped the students who know how to take advantage of it. And you talk to some young people who have been adept at using digital technology to enhance their rate of learning in ways that are really hard to do with the traditional schooling system, which is not so personalized, and everybody kind of has to be at roughly the same level. And it just fills you with hope for the future when you see the extent to which it can improve human potential. But at the same time, on average, I think the effect has probably been negative, because not everybody has the right social economic background, the right self-control, parental guidance, and all the other ingredients that go into making productive use of the technology when you're a kid and don't have the right level of self-control to be able to figure it all out for yourself. And I think that's perhaps what is most likely with AI as well. So when I think about me and my wife, for instance, we think about AI a lot in the context of our own kids and their education. So we have a lot of time to figure things out and set up the right infrastructure for them. And we use AI very productively in the course of their learning. And I've built many little apps myself with AI for my kids to learn, fractions or whatever it is. And it's great. It's been such a positive force for them. I don't think if a kid is left to their own devices with AI apps, things are going to go so well. And unfortunately, parents who lack the time and expertise to really figure out the right interaction for their kids with AI are going to find themselves in that position, and it really worries me.
Yeah, that whole bifurcation of society, between the haves and the have-nots, has many axes, and this is a new front in that. I think, and it also, again, great illustration of your normal technology thesis. You think about AI in education, and you have this idealized vision of the personal tutor. I mean, my gosh, it seems like the diamond age, Neil Stephenson's book about, the ladies primer, and, instead what we have is this system where it's going to be very slow to be adopted, because the system itself will need to change profoundly in order to take advantage of the technology. So anyway, so that I guess is, we've already kind of covered this, but HM says, what do you see as the ideal role of non-corporate AI providers such as Khan Academy's AI Tutor or government AI services, especially for meeting core human needs for everyone?
Yeah, let me start with the government one. I think governments really need to figure out a tightrope that they need to walk. On the one hand, if they adopt AI too hastily, what's going to happen is it's going to be error prone. They might trample on citizens' rights when things go wrong. In some cases, there's going to be bad press. Things like this have already happened. So there was a story, I think it was in the markup, about how ProPublica's, pardon me, either the markup or ProPublica, I was going to say, I forget which one, about how New York City's chatbot was telling businesses to break the law. Not on purpose. This was the result of hallucinations, but there was a lot of bad press, and people lose confidence when things like this happen. On the other hand, if they are too slow and take too long to, for instance, just to give one of many examples, to use AI to help citizens with tax advice, which, while risky, I do think is a genuinely useful application of AI. I use it for that purpose myself. If they're too slow to deploy these things, then I think people are simply going to turn to the private sector for all kinds of things that are better provided by governments, and the private sector is going to provide those services with even less oversight and care over errors and biases and so forth. So that's the tightrope that governments need to walk. And perhaps for that reason, NGOs have a huge role here. They can maybe move a little bit faster than governments can, but at the same time, they can be more deliberate than the private sector and make sure that they're truly considering the public interest in the way that they deploy AI.
This is a really interesting question from SI. It's a wonderful statement. It said, would a good policy for any AI-driven use case be that its KPIs should mirror whatever the owner of that product would want for themselves, their kids, their family, or their loved ones?
Yeah, I mean, I like that. I think that's.
I love it.
It's a good ideal. It's a good ideal if you're at a company and you want to figure out what KPIs you want to set for yourself or your own product or whatever. As a way to regulate AI, I don't know. I think it's hard to actually enforce something that idealistic.
Yeah, it reminds me a little bit of Rawls's veil of ignorance. Yeah, too. Anyway, I think it's a wonderful goal, but like I said, hard to implement if we rely on. I also think of this wonderful passage from Lao Tzu. It says, "Losing the way of life, people rely on goodness. Losing goodness, they rely on laws." And we need to kind of go back up that hierarchy if we can.
I love all these quotes that you're throwing out.
Yeah. Anyway, let's see. TB asks, broaden your analysis to the global AI race. China seems to be very aggressive in accelerating diffusion of AI as a national imperative domestically by encouraging its use internationally with free and excellent open source models. Similarly, with places like the UAE. The industrial revolutions were won by the countries that diffused new technologies the fastest, not those that invented them. How does that impact your theory?
Yeah, so that's exactly where we're coming from. So this thesis is from Jeffrey Ding, political scientist, I think at Georgetown, and he has a book that I think is called "Technology and the Rise of Great Powers," and not just the Industrial Revolution, but many past waves of general purpose technology. If one country takes the lead in invention, it doesn't matter that much. Other countries can catch up quite quickly to that knowledge, but to diffuse the technology through different industries and the public sector to train people to use it properly, that stuff takes decades, and that's where the pace can really vary between different countries. So on that note, China is innovating very quickly in AI, as shown by DeepSeek. But does DeepSeek show that it's diffusing quickly in China? That's much less clear. And in fact, the aforementioned Jeff Ding on his newsletter had a note very recently about the diffusion of AI in China, and he seems to think it's going much slower than what the innovation would suggest in terms of DeepSeek. Again, these are different processes. One doesn't imply the other. So I know nothing about the rate of diffusion in China. I'm relying entirely on his analysis. So I'll say that your framing is exactly the right one, but it's not obvious to me that China's ahead.
Yeah, speaking of Those things, again, it just illustrates so powerfully why this framing of normal technology is really a useful tool for thinking about the problem. Because if you think of it as something magical where AI itself will just burst the dams of society and will reinvent the world, you act one way. If you understand that there are all of these structural forces that are going to constrain, then you can identify those ones that you want to go after, and it's such a central idea that if you really understand the problem correctly, you can actually, as an entrepreneur, for example, or as a business, you can actually tailor your solution to the real problem. Whereas if you think it's just something you wave your magic wand and it just happens, then half the time you'll be surprised. You think again about some of the great successes. Both Google and Amazon identified early on that one of the bottlenecks for their respective service was speed. And they both super focused on, like the speed of a query. The speed of a query in the case of Google and the speed of delivery in the case of Amazon. They'd understood a constraint and they went after that constraint. And I think part of what I take away from your normal technology frame is understand what will constrain the spread of AI and go after those constraints.
Exactly.
DR asks, will the financial gains from the AI revolution mostly benefit big tech, or is there a real opportunity for individuals and small startups to thrive?
Yeah, I hope it's not something that's going to mainly benefit big tech. I mean, big tech will benefit, but just again, to go back to the example of software development, while there are many concerns about, a seeming slowdown in hiring software engineers, especially at big tech companies, that's not the right lens to look at it. I think we have to look at the fact that it's gotten much easier to use AI assistants, not vibe coding, but really knowing, how to use AI to augment software engineering. It's gotten easier for smaller teams now to build more complex software. So my hope is that this will actually lead to more of a flowering of software startups. So that's one way in which it actually advantages the little guy. I think there are many others. So I think that overall the answer is going to be complex. It's not predetermined. It depends on what we do collectively, but I'm cautiously optimistic.
Yeah. JD asks, with AI drastically reducing entry-level jobs, how are industries going to get experienced workforce 5 to 10 years in the future when the next batch of experienced workforce doesn't exist?
Yeah, this is a real concern. I won't sugarcoat it. I think this is a big one when we talk to policymakers. This is one that we emphasize. And I think the reason this is a real concern is that it's been to some degree a concern even before AI. So when you look at, just to give one example, medicine, right? So training after medical school, training a medical resident for many years before they can practice on their own, that is very expensive for a hospital. Most hospitals can't do it. Some of the bigger hospitals are able to do it because having a residency center brings them other harder to quantify benefits, like their prestige goes up, they're seen as a center of excellence, so that draws in more qualified physicians and so forth. So these kinds of years-long training programs in medicine and law and many other fields are only able to exist not on their own economic merits. They don't pay for themselves, but because they bring these other ancillary benefits to the employers that provide these training programs. So these are already fragile arrangements. And so now on top of that, when you introduce the shock that is caused by AI, when it becomes even less profitable for employers to have these, again, years-long apprenticeships where the employees are not fully productive, they start to question, do we want to hire these junior employees at all? And so this reframing also points to what the solution is. In many cases, a lot of these, whether it's residency programs or certain other kinds of, I'm using the term apprenticeship loosely, obviously, it's not precisely apprenticeship, but these programs only exist because they're partly subsidized by the government. And so I think we're going to need much more of that in order to preserve these training pipelines in the age of AI.
Yeah, I think that's right. And it also does require a shift. I do, in my book, WTF, I describe our current capitalist economic system as a kind of first rogue AI because it's told our businesses that they should be optimizing for profit above all else, and for shareholder value. And so it's not really even profit; it's shareholder value, which means if you can get the profit, the shareholder value by going public with a unprofitable company, that works too. But that leads to all these short-term incentives. Get out while the going is good and leave, everybody else with the consequences. And I think we really have to think about that here. How do we rejigger our entire system so that it's less short-term oriented? Because these effects have to be dealt with. We're going to end up in a world of hurt if we just kind of race to the point where a bunch of investors and startups make a ton of money and then leave society with a whole lot of unsolved problems.
Yeah, agreed.
Okay. JG asks, what should kids learn now to be ready for the future?
Yeah, that's a good one. I think we have in my view, a weird education system, and I've said this publicly for as long as I've been a professor. This concept that you stay in school for 20 years or whatever, right, through the end of college, and then you're fully trained, and then you go off into the workforce and just use those skills that you once learned. Obviously, we know that the world doesn't work like that, and that's a big part of the reason why the college experience is so miserable for so many students, because they'd actually rather be doing stuff instead of in this decontextualized environment where they're supposed to just passively absorb information for using it someday in the future. So I think AI is an opportunity to fix these deeply broken approach to education. I think kids can start making meaningful contributions to the world much earlier than they're expected to. And that became much more true with the internet. Anybody could throw up a website or an app that does something useful. It's becoming more true with AI. So that's one half of the story. You can learn much better when you're actually motivated to produce something useful. And the second half of the story is it's more true than ever that we should never stop learning. And the way that any job is done is going to keep changing every 2 years as AI capabilities advance, and the role of the human is more around supervising AI than doing a lot of stuff themselves. And so the most important thing perhaps that kids can learn is learning how to learn and getting these meta skills around the right kind of human AI interfaces and partnerships.
All right. Well, with that, we're out of time, and that actually is a perfect place to end. Thank you very much, Arvind, for joining us. And I'm sorry we couldn't get to all the questions. They're continuing to come in. Thank you very much, everyone, for attending, and we'll see you next time.
Thanks, everyone. Thanks, Dan.